is the zero governor. Yeah. The zero governor is the actual valve, the actual gas valve. The regulator is works on the basis, isn't it, that the fan speed is pulling the valve off its seat. So the greater the negative pull created by the fan up that tube in the valve there, the more it's going to lift the valve off its seat, and the more gas gets pulled through to mix with the air to push into the burner. And the fan ramps down like we did on the commissioning mode on that boiler. It's an idle setting. The negative pull on the mixing tube and the valve goes down as well, doesn't it? And therefore the actual diaphragm, the negative pressure on the diaphragm slackens as well, lessens, and the valve goes closer to its seat again. So the fan is the throttle. The fan is moving that valve up and down. Nothing else. So it's under negative pressure, and that's matched by the positive pressure of the gas going in. So basically, if you've got 4 millibar of gas or 4 millibar of negative pressure caused by the fan, you'll have 4 millibar of positive gas pressure beside the diaphragm going in. That's why you will not get a burner pressure reading if you put a tube on there. You put a U-gauge on there, you'll get 0. You'll get a reading. You can get an inlet pressure, so you get a working pressure at the appliance. You won't get a burner pressure. Ideally, it should be Zippo anyway, it should be nil. If it's too far off that mark, there's probably something wrong with the settings on the valve, i.e. the offset settings. Yeah?
Yeah.
Right, to test. You're going to have your gas on, and then we're going to have, make sure your reset button down there is set, it's off. So you push your reset button so you want it going again. Sometimes it will switch itself off when you first switch it on. Other times it's left from the previous person that's been on the rig, you know what I mean? So it's an easy one to miss, isn't it? But sometimes if that tube's down here somewhere and you're still looking at that and thinking it won't go on, just make sure you press your reset. It's purging itself now. So now what's happening, the fan's going, it's purging itself with any gas and air in the exchanger. It'll go through a purge cycle so that when it lights up it's not going to explode inside there basically. So purging the gas and air, then it'll go for ignition mode, power sent to that ignition probe, which is about 700 degrees, 704 degrees spark across there to 90 gas. So now the gas and air is in the burner. Now what's going to kick in is that flame rectification. And the flame rectification is simply when the PCB knows it's a light, there's a flame on there, it will stop the spark process and send a continuous current through that probe. And it comes through as an AC current. Alternating current will be sent into the actual burner. Now the probes are near to the burner surface. The burner surface is a greater area. It attracts what it calls, it ionises the signal. It ionises the current going through the flame. Passing it through the flame does that. Particularly when it's close to the burner, the base of the flame. Because what electrons tend to do, the negative ones tend to jump ship, if you like. They're attracted to the casing from the burner. And they end up jumping on there. And then what happens, the time that signal reaches the other probe, there's no room on that probe for all them negative ions to jump back on again. It's the most simple term. Basically it flattens the signal, it ionises the signal. The electrons are replaced with more positive electrons. Yeah? And that AC-DC that goes from a negative current to a positive back to negative, it flattens the negative side, the electrons there, they disappear to a degree, and you end up leaving an AC current, a nice flat signal that goes back to the PCB. When the PCB receives that AC current, it knows there's a flame there. Ionisation. Yeah, that's what it does. So it's instant. And this instant is that as soon as there's no flame, it will shut the flame, it will shut the valve off, shut the solenoid, cut power to the solenoid, shut it down. Then it'll go through a purge cycle again. And it will try to reignite. So now it's purging the gas and air from the exchanger. Now some boilers will try 2 or 3 times, multiple times. Other boilers might just try once and go directly into lockout. But it's instant. It's not like a thermoelectric valve. A thermoelectric valve's got a thermocouple in the frame. All the time that thermocouple is hot, it will produce a little bit of electricity. So it might be a few seconds, normally 20-30 seconds on a fire, before it clicks off. Because while it's hot, it's still producing a little bit of electricity. As soon as now it's trying to reattempt ignition. There's no flame there, so straight away, PCB recognises it. That's shorted back as an AC current. Went in AC, tried to spark, it's shorting back as an AC current. If it shorts back as an AC current, it knows there's no flame there, it sticks it into lockout. So, waits for an engineer to come along, like you guys, to find out what the problem is. Might be a break in the mains, it might be someone's interfered with the mains, they've done work on the gas, whatever, and they've interrupted the supply. But as long as it stays interrupted, it's going to stay off. So it's instant, it's within a second. It doesn't have to cool down. As soon as that flame's not there, that signal shorts directly back to an AC current, back to the PCB. So it acts instantly. Yeah. Some probes, you might see some probes on some burners. There's one next door in the base next door. Might have, there's one, in fact, third one down here. It's got one probe to it. Just got one, so lads like look at it and think, why is it all? Why they're looking for 2 probes all the time? These boilers here, the ideals and raised heat, they use 2. It doesn't matter. The ones that use 1 probe, that signal is short into the casing itself. It shorts to the burner, and an earth lead attached to that burner will pick that short up and take it back to the PCB. And it will take it back as a DC current all the time it's shorting through the flame. So whichever way it receives it, very short, if it receives that short as a DC current, it knows there's a flame on, it will keep the solenoid open and the gas open. If it shorts back to it as an AC current, it's not ionised it. If it's not ionised it, it knows it's not gone through a flame. Therefore it will cut out, it will cut the solenoid.
So it's just turning it from AC to DC there.
Ionisation, a flame close to a burner will ionise the flame. Ionise the signal rather.
Okay.
So it ionises it. It flattens it. It converts an AC current to a DC current. It's a rectifier. You can get rectifiers in all sorts of units now. There's rectifiers in each of those units down there. A rectifier will, for example, change a lot of currents now. A lot of fans in boilers work off DC current because it's a more stable current to work with. More Europeans, America and Europe, they use DC current a lot because it's a more stable current. It runs in a straight line from positive to negative. And electrons, they're not moving backwards and forwards from negative to positive all the time. They're going down line, down that cable or down that wire. And AC current, because it's alternating, is moving backwards and forwards all the time, all the way down cable. It's less stable. DC current, electrons move in one direction, from there to there. It's like a battery. Battery's the same. Battery is a direct current. It's a chemically produced electron current that moves the electrons, makes them move in one direction only. So a battery is a direct current. Not turbines produce that. It's the way we produce electricity in this country, basically. Because we use dirty great magnets. When you think about it, size of this room, big turbine, in the middle of that, you stick a magnet. The magnet has got a negative pole it's got a positive pole. You ever try playing the magnets at home when you're at school? Try and push them together. Okay. They won't go together unless you turn them round.